All right. Good morning. My name is Saige Martinez. I want to thank you all for taking the time to be here and to listen to our presentations. Before I tell you more about my project, let me tell you about myself. I was born and raised in Las Vegas, New Mexico, to Richard Martinez and Krupskaya Ugarte. I am the second oldest of 9 siblings, and I am currently serving our country and state as a soldier in the United States Army. In May of this year, I graduated from New Mexico Highlands University with a Bachelor of Science in Mathematics. In January, I will begin my master's education at the University of New Mexico, where I will be studying applied mathematics. I've experienced a whole lot in my short 25 years, but more than my experiences, I'm extremely proud and thankful for all my loved ones. They are the reason why I'm here today. I'm also grateful for Brian, Cecilia, and all my classmates. I have learned so much from them over these past 10 weeks, but let us move on to my project. Drones have had a positive effect on search and rescue operations across the country. The most prominent effect being the amount of time required to locate missing persons. But here is the problem. In June 2014, a 15-year-old boy was separated from his church group while hiking the Sandia Mountains. The boy was found a mile up from the trailhead, stuck on the ledge of a cliff. According to the authorities, the boy had fallen 200 feet to a ledge, which was 500 feet up from the ground. It took search and rescue personnel 2 hours to reach the boy. In December 2019, a man got lost while hiking the Sandia Mountains. He was a quarter mile from the top parking lot, but stuck in waist-high snow for a total of 12 hours. It took search and rescue personnel 1 hour to reach the man. Though drone technology has had a positive effect on search and rescue operations, the time required for search and rescue personnel to reach missing persons has gone unchanged. For victims, time is of the essence. The more time a missing person spends exposed to the elements or injury, the less of a chance they have at surviving. The solution? Beacon of Hope, a device that can be dropped from a drone to a missing person's location to provide the person with essential first aid and communication while waiting for search and rescue personnel to arrive. Let us explore what a device like this is made of. This device is controlled by an ARM Cortex M4F 32-bit processor with a 2.4 gigahertz Wi-Fi coprocessor. Impact is determined by a 3-axis accelerometer. The white LED is included to double as an SOS signal and a source of light for victims in case of low light conditions. Altitude, pressure, temperature, and humidity data are collected by a BME 280 module, and latitude and longitudinal coordinates are collected by a GPS module. Video is captured by an ESP32 Wi-Fi compatible development board with the camera module, and everything is powered by a 3.7 volt lithium-ion battery. Here's the code used to operate this device, written entirely in C. While in flight, this device is always searching for an impact. Impact is determined when total acceleration exceeds a specified threshold. Once this happens, the system is initiated and begins flashing the LED in an SOS sequence and collecting and transmitting data about the environment and the missing person to the cloud for decision makers to see. For those of you that are interested, the full code can be found on my GitHub page. A link will be provided at the end of the presentation. Here's a 3D model of the electronics enclosure that I rendered using Fusion 360. The body is 85 millimeters tall, 71.5 millimeters in diameter, and 1.5 millimeters thick. The opening is 44 by 71.5 millimeters, and in this current design, the electronics take up 50% of the interior, allowing for the other half to be used for first aid supplies. Here is a demonstration of the device. Shown is the electronics. The electronics are then loaded into the enclosure and connected to the LED wires. First, the beacon is dropped from 1 foot. No light. Then 2 feet, no light. Finally, it's dropped from 3 feet. The light turns on and the system is activated. Once the system is activated, the device begins sending data to ThinkSpeak IoT platform. And this platform, altitude, temperature, humidity, and GPS location are displayed. Once the device lands, the missing person can then open the beacon latch to access the first aid supplies. This device is not only applicable to search and rescue operations, but to all emergency and military operations. Adapting the device to suit the needs of each space would require long-term commitment and further funding. Some ideas for future capabilities include relying on only one microcontroller, implementation of a two-way microphone to communicate and instruct missing persons of self-aid, radio compatibility, implementation of thermal and infrared imaging for environmental and missing person temperature readings, as well as low light conditions, implementation of an automatic radio antenna to avoid damage during impact and provide a more condensed form factor, a smaller form factor of electronics through printed circuit boards and condensed sensor modules, a larger form factor of the electronics enclosure to provide more space for first aid supplies, a low power mode until impact to reserve battery life, and a software command center where device data and orientation, environmental data, and missing person data are displayed for decision makers. Again, thank you for your time. Are there any questions?